Hello, this is Mark. I'm going to do a brief presentation on end-of-waste options for biodegradable waste subjected to biological treatment, specifically compost and digestate. Roadmap kind of looks like this. It starts off simple for those who aren't familiar with anaerobic digestion, and it starts slowly getting more complicated when we talk about the solutions to the issues that we'll be talking about later in the presentation. So first off, what is anaerobic digestion? So anaerobic digestion is a biological process used to treat organic waste. Organic waste is roughly 1/3 by weight of percentage-wise of the weight that we dispose of every year. It can come from multiple sources, namely food waste, what you don't eat, yard waste, trimmings from your landscaping, leaves, etc., and then also it can also be scavenged off of municipal solid waste with objects such as soiled paper. Anaerobic digestion is a complex biological process. It takes 4 different steps using thousands of different types of microbes. But if you look at it as a black box, essentially what happens is you put in organic waste, it goes to the digester, and you get 2 outputs. You get biogas, which is essentially a raw form of CO2 and methane, and you can use that to power your heaters, a turbine. You can use it to create electricity. You can use it to fuel fueling trucks. So that's one basket of benefits from anaerobic digestion. And then you also get we call it a digestate, which is what's left over of the organic material after the process. And that can be used, as we'll talk about later in the presentation, as an organic fertilizer. So why is this important? So why would we go through all this complicated stuff in biological processes when we could just throw this in the landfill? And the reason why is that when you take organic waste, it goes in the landfill, it degrades, similar to an anaerobic digestion process, but in creating methane. However, landfills are not efficient at capturing this methane. It gets released to the atmosphere, and this methane is 30 times more potent as a heat-trapping gas than CO2. Additionally, it's almost like it's throwing away a product that can be turned into compost. Compost is very important to agriculture, and much of this organic waste with just some treatment can be used as compost. Compost is beneficial because it enriches the soil, and it also traps moisture, which is particularly important in drought-stricken areas like California, which we've had some droughts lately. So speaking of California, as well as Europeans have done this, earlier than us in the 90s, but California has identified that anaerobic digestion and composting is the new mandated alternative to wastefully placing organic materials directly in a landfill. And they've enacted AB Assembly Bill 1383 that dictates diversion of organic material by landfills. And there's a few different goals in terms of how much percentages by what dates. But there's still a huge problem though. Organic waste is not as pretty as it looks. This is a photo I recently took at a plant here, and you can see on the right hand side, you can see some apples, some fruits and vegetables, but majority of what you see is contamination, either plastic. Someone might put plastic spoons in there, lots of packaging, and all that stuff. And if we want to be able to sell this as compost, all of this needs to be filtered out. So luckily there's technology for this. As referenced before, Europeans got on this a little bit earlier than us in the 90s, and they've developed lots of technology to do this. So on the upper left hand corner is an anaerobic digestion facility plant on a conceptual level. So that large, and I'm not going to go into too much detail here, but essentially what happens there is similar to that schematic there. The biogas is created, it goes into a gas bladder. It can either go through a turbine to create electricity, or it can go through an upgrader to make fuel gas to run garbage trucks. On the other hand, the digestate is taken out the other end. Unfortunately, that contamination is still part of the equation and needs to be dealt with. So furthermore, the material in the digester is not fully stable to be put on plants, so it needs to go through a stabilization phase, which is typically composting. Composting is great because not only does it stabilize it to make it safe to put on plants, it also dries the material. Once the material is dry enough, there's enough of a delta in terms of density that densimetric tables can be used to filter out the inerts, plastics, and contamination, so we can make perfectly good compost. Economically, this is very beneficial for everyone because we also have goals in California and other states in the union to reduce the amount of carbon intensity of our fueling system. To do this, that carbon is from the methane of our biological reaction is used to offset carbon that we would get from the ground. California is incentivizing this program through the LCFS program, or Low Carbon Fuel Standard, and it's a market-based system where credits for reducing carbon intensity of our transportation fuel are bought and sold, and it's a supply-demand sort of system. So right now, before too many of these plants are built, the supply of these credits are scarce, driving up the price. So it's a golden opportunity for those to get into this industry and help solve this organic waste problem while also reaping the benefits of the subsidy before others cash in on this benefit. Full disclosure, I work for a technology provider of anaerobic digestion and composting systems. If you'd like to learn more, you can go to zwenergy.com, email me directly. Thank you for listening to this, and I hope we can speak soon. Bye.